Hello everyone and very welcome to the channel. I just stumbled upon this very interesting research paper by Meta where they have come up with this new model called as MoMA. The model hasn't been released yet, so we will just be looking at the architecture and the nuances of this research because I believe that this could be a big thing and we might see a very efficient and performant model coming out of it very soon. MoMA is a new modality-aware mixture of expert architecture designed for pre-training mixed-modal early fusion language models. Modality-aware refers to the model's ability to recognize and process different types of data, such as text and images. Mixture of expert or MOE is a technique where multiple models expert work together to achieve better results. MoMA processes images and text in arbitrary sequences by dividing expert modules into modality specific groups which exclusively process designated tokens. This approach enables semantically informed adaptivity, allowing the model to adapt to different modalities while maintaining meaningful representations. Recent autoregressive mixed modal foundation models such as Chameleon have shown remarkable capabilities in tasks like visual question answering and multimodal content generation. But scaling these models present significant computational challenges. To address this, these researchers at Meta investigate a routed sparse architecture, which you can see on your screen too, which has been proven effective in scaling language and vision specific foundation models. Their insight is that modalities like text and image tokens possess distinct information densities and redundancy patterns. By incorporating modality specific modules, the model can better capture features specific to each modality while maintaining strong cross modality integration, as you can easily see on the screen. Now, if you look at this architecture more closely, this is where multimodal early fusion is happening. For example, in the left section, which is marked as A, the early fusion architecture processes interleaved text and image data as a unified token sequence using a transformer model. And in the section B on the right hand side, it's a detailed architecture of the mixture of modality aware expert MoMA transformer block where layer norms and the residual connections of attention layer are omitted for readability. The input sequence of tokens are first routed to different expert groups based on their modality. It undergoes learned routing within each group and then have their output restored to a tensor of the original input shape of the FFN module. So this methodology has been, I think, inspired by Chameleon, as the authors have adopted this as the base transformer architecture and introduced sparsity along two dimensions, width and depth. For width, they have applied mixture of expert, dividing expert into modality specific groups. For depth, they apply mixture of depth or MOD that allows tokens to selectively skip computations at certain layers. They have also used expert choice routing to ensure load balancing and maintain a static computation graph. They also have shared this flow, or you can see the architecture, where you can see that they have used sigmoid as a non-linearity in the router scoring function, and that enables independent calculation of token to expert affinity scores for each tokens. Also, they have introduced auxiliary routers which predict the likelihood of an expert selecting a token solely based on its hidden state representation. These routers are trained after the main model training is completed and employed during inference to ensure causality. Let's spend a bit more time on this because this seems quite interesting to me. So, not only this, but these authors have also experimented and demonstrated substantial pre training efficiency gains with MoMA. The MoMA 1.4 billion model achieves 3.7 into overall flop savings, for image processing compared to compute equivalent dense baseline. Combining MoMA with MOD has further improved flops, savings to 4.2%, 4.2 times overall. But this combination hurts performance in causal inference due to increased sensitivity to router accuracy. And this paper has also demonstrated that modality united upcycling can enhance MoMA's performance. So all in all, real good stuff. Very impressed by it, and can't wait the model to be released. And then, as soon as I get my hands on it, I'm going to create another hands-on video, and we will test out all of these claims in the light of various benchmarks. I will drop the link to this paper in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.